So winding up our intro to algebra and this review of arithmetic section is A8. So we've gone through adding and subtracting terms in algebra. Now we're going to finish up with the other two operations of multiplying and dividing terms. So we're kind of switching the rules here. Well, not switching the rules, but they're different rules. So just want you to make sort of sense of this, where in adding and subtracting, we were looking for common or like terms. And when we added that, the coefficients added together and the variable components stayed the same. So 2x plus 3x equaled 5x, right? This is adding and subtracting. We are now going to move on to the other family of operations, so multiplying and dividing. So multiplying and dividing terms is different. The variables are going to change. What we focus on are common bases. So if we see A's, we're going to do something with the exponents. If we see B's, we're going to do something with the exponents. And so really making some sense of this, we really need to think back to exponential notation. So we talked about it as being a shortcut for writing things, right? A times A times A times A times A is A to the 5. If we had nothing on our variable, it's assumed there's a 1 there. This one's a bit of a tricky bit. If anything has a 0 exponent, it's not actually a letter. It is now the number 1. And I'll try and come back to that one in a few of these examples to kind of prove that to you a little bit. So finding the product, remember that's multiplication, of algebraic terms to multiply expressions with the same base. So we're staying with the same letters. If we have the same base, so if the base is repeated, you're going to keep the base the same and add the exponents. So here we have the pattern. And if that doesn't make sense, sometimes it's nice to expand this out to make some sense of it. So if I had a cubed, what that means is that I have 3 a's multiplied together, right? That's a cubed. And then this says I'm going to multiply it by a to the 4th. So that means that that's actually 4 a's all multiplied together. Now the pattern says that I'm just supposed to add those two. So this would be a to the 3 plus 4, or a to the 7. If I take a look at the expanded out thing, what I've got here is 7 a's. That's a to the 7. These are the same answers, one derived by the pattern and the other derived by kind of expanding it out. Now, mercifully, we don't have to expand every single one out, right? If we follow this pattern. So let's try this pattern on these ones. So here we have common base A, right? So if we have the same letter, then we can add those exponents. And I simply show it like that because it gives me a place to write it down. So that would simplify. Remember, we're not solving these, we're just simplifying these expressions to a to the 12th. B has common bases of x. So if we're multiplying those together, there is a 1 understood on that x. So writing this out, it would be x to the 1 plus 8. The base is staying the same, but the exponents are being added. So that'd be x to the 9. The next one is in here. It came from a resource that liked to kind of prove things to you. And sometimes with arithmetic, you can actually prove something you're learning in algebra. So that's why this one's in here. So in this case, it's weird in that you have the base of 3, right? So if we follow our pattern, base of 3 and 2 plus 4 would give me 3 to the 6. Well, if I use my y to the x button, that would give me 729. If I wanted to, I could use my y to the x button on this. I could evaluate it the other way, right? Kind of BEDMAS style. I could have 9 times 81. That's also 729. So in evaluating this as we can, because it's numbers and arithmetic, we can kind of add some some support to this pattern that we're talking about. So the next one, D here, has 3 y's, and they each have an exponent on them. So you can imagine expanding that one out. Really what we're doing is adding all those exponents. And so I get y to the 10 in a simplified answer. E is a little different. So E, we've been used so far to having the same base. We don't have the same base here. The best you can do with this is just simply rewrite it all smack up beside each other, because that implies multiplication. And so that would be the end on that one. I just caught the answer key I was looking at, had a mistake in it. Oh dear. Okay, last one, y to the 7 plus 1, or y to the 8 would be the answer of that simplified. So this side only had variables. We're now going to put some coefficients in here. You simply multiply the coefficients and then do what we were doing with the variables over here. So 2 times 3 gives me a 6, and the x has a 3 and a 5 on it. So my final answer is 6x to the 8. Give these ones a shot. I'll try and be quiet as you go through them, and I'll write the answers out. I'm going to skip showing my steps on the last 3. Hopefully I didn't make a mistake. Last one has a lot going on. Oh my goodness. And that would be multiplying terms in algebra. We're going to do the opposite of this in division of terms. And so again with this one, there is a pattern that we can understand. So the pattern means is much like the others, but instead of adding, you're actually subtracting those exponents. If you were to think of it as, expanding out, we could do that as well. So we could do, if we had a to this, I'm going to do it down at the bottom because I know there's a bit more space down there. So say we had a to the 7. So this would be a bit of a proof. Space to expand it out. A to the 7 divided by a to the 4. You might notice it's the reverse of the one that we did in multiplying. So I'd have 7 a's. Oh, that's 5. I didn't leave enough space. There's 7. And then there'd be 4 a's down below. Something divided by itself is 1. I could think of these as just canceling out, right? They each reduce to 1, which we don't have to write in front of anything. So the answer for this would be just 3 a's on top of my fraction line, or just a cubed. So this would be showing it all expanded out. If I show the pattern, it would be a to the 7 minus 4, or a cubed, right? Either which way, whether you want to see it expanded out or you want to follow the pattern, both of those are valid ways to look at these things. Okay, so let's go back to this. We want to follow the patterns likely on these. I'm not going to expand them out. So we have m as our common base, so I write that down, and it's 9 minus 6 when I do that division. So m cubed would be the simplified answer to that expression. M6 minus 1, remembering that invisible 1 on the m, so M5 as an answer. There's more on some of these, so remember you're only subtracting or adding the exponents on the common basis. So we have r to the 5 minus 3 and s to the 6 minus 5. So my final answer would be r squared s. S would be to the 1. If you write it there, it's not wrong, but you don't need it there. This next one is interesting. You have a to the 2 and a to the 2. So if you wrote it out with a pattern, it'd be a to the 2 minus 2, which is a to the 0. Do you remember I said a to the 0 is 1? Anything to the 0 is 1. We could also think about something divided by itself is 1, right? Which gives us, we can ignore those a's and just do b to the 4 minus 3. Or, final answer, just a b. The last one here in this column, we have x to the 3 minus 2, and this y doesn't have a buddy. It's just going to stay on the top as y to the 5. So we'll simplify this as x and then just write it beside the y to the 5. So those are just letters. Over here we've moved into coefficients as well. For the most part, we end up with the bigger number on the top dividing evenly out. I think there are some in our coursework where the bigger number's down below, in which case you could think about them as simplifying fractions if you wanted, right? I'm going to do it as 4 divided by 2 because that seems easier. And then it's x to the 3 minus 1. So the final answer would be 2x squared. Last ones, and again, they all divide as these coefficients evenly. I skipped showing my work on that one. Hopefully I won't make a mistake as I take some shortcuts. So remembering anything to the 0 is 1 is maybe a little bit of a tricky thing. And like I said, sometimes we will have these that the bigger numbers down below. So maybe your answer stays as a fraction. Maybe it's easier to think about it there. You'll run into those, and if you have trouble with them, let me know. So one last page, we're going to try and put together this adding and subtracting and the multiplying and dividing together in one. So sometimes when you mix up the rules, things get tricky. Remembering in adding and subtracting, you combine like terms. You add or subtract the coefficients and the variables stay the same. For multiplying and dividing, you add or subtract on common bases. So they're different rules, but they don't undo each other. So let's take a look at this one. Here we have just multiplying, so we have w to the 2 and the 1 and the 3, and we have z to the 3 and the 1 and the 4. So we get w to the 6 and z to the 8 as an answer. Work through these ones. I'll put the answers here. There is a trap waiting for you on this page. These two. But keep going. You're doing great. Oh, here we have one. So this one, we can see the coefficient down below is bigger. So we end up with a 2 down below. And then we can do the rest of it up the top, right? Divide by 3 and divide by 3. You get the 1 on the top and the 2 stays down below. Then we'd have a to the 4 still on the top and b to the 5 minus 4. So making this make some sense, how I would write it would be a to the 4 on the top, no need to write that coefficient of 1, and then b to the 1, but I don't need to write it like that. And then there'd be a 2 down below. That's a bit of a tricky one too. Oh my, these are big numbers. Let's see where we get. Oops. That one wasn't quite so bad. So these ones are a little different. So they combine the rules here. So here we have adding and subtracting, right? Where we have exactly like terms. So you add the coefficients and the variables stay the same. Then I'm going to do the dividing. So I divide out the coefficients, I'd get a 7. I have a to the 2 minus 1, and then the b 1 minus 1, or they could just cancel out. So my final answer here would be 7a. Give the last one a shot on your own. You should get to 5y. So that's the end of our Unit A.